Hello and welcome to Preparing for Exam AB-731, AI Transformation Leader. I'm Andrew Conniff, a Microsoft technical trainer focusing on Copilot and AI strategy adoption. This session is designed to focus on what the exam expects you to know, not to teach every concept in depth. The goal is to understand the skills covered in the material and which concepts might be covered so that you can better prepare for the exam. The certification journey leading to the AI Transformation Leader credential shows how the exam prep series fits within the broader path. The journey begins with recommended but optional Microsoft training, such as self-paced learning and instructor-led content. This is followed by practicing real-world AI skills, such as evaluating AI opportunities, aligning AI investments with business goals, and driving adoption across teams. The exam prep series then serves as a checkpoint to identify knowledge gaps before scheduling and passing the AB-731 exam, supporting by resources like documentation, learning paths, and the official study guide. The objective domain breakdown shows how the exam is structured across three core areas, with each objective carrying specific weight. Objective 1 focuses on identifying the business value of generative AI and represents 35 to 40% of the exam. Objective 2 covers identifying benefits and opportunities for Microsoft's AI apps and services, also weighed at 35 to 40%. Objective 3 focuses on implementation and adoption strategies for Microsoft AI solutions and accounts, and for about 20 to 25% of the exam. And these weightings indicate how questions are distributed, reinforcing that while higher weighted objects may appear more frequently, all areas must first be understood to successfully pass the exam. The exam prep series objectives clearly define the purpose of the content within the certification journey and focus on identifying what is covered in the exam, gaining insight into how to prepare and determine which concepts should be prioritized or revisited for further study. Let's start with the first objective: identify the business value of generative AI solutions. This slide outlines the full set of skills for Objective 1. It's important to recognize that these are broad and scenario-driven rather than deeply technical. The exam is going to expect us to understand how to distinguish generative AI from other AI types, when to use it for business value, and how to evaluate trade-offs like cost, reliability, and data quality. We should also be able to be comfortable with concepts like prompt engineering, retrieval augmented generation, or RAG, and the role of secure and responsible AI, particularly in enterprise environments. Let's go through these in a little more detail, starting with understanding the difference between generative AI, traditional machine learning, and rule-based systems. At a high level, generative AI creates new content like text, images, or code, while traditional AI analyzes existing data to classify, predict, or detect patterns, or rule-based systems that follow predefined logic without learning. The key exam insight is to recognize which approach fits a given scenario. Content generation points to generative AI, prediction or classification as machine learning, and fixed repeatable processes point to rule-based systems. From an exam perspective, be prepared to evaluate trade-offs like choosing the right tool rather than assuming generative AI is always the answer. Understand that generative AI is flexible and powerful, but probabilistic, meaning outputs can vary and may not always be accurate, while traditional models and rule-based systems offer more deterministic and predictable results. Questions will often test your ability to match the tasks to the correct AI type, so focus on identifying the nature of the problem being solved. When preparing for the exam, understand how to define the task, assessing whether it's structured or open-ended, and consider data sensitivity and scale. Next, apply a simple decision framework. If the task is content creation or conversational, then use generative AI. If it's prediction or classification, use traditional machine learning. And if it involves enterprise data, use generative AI with grounding. From there, choose the approach. General purpose models are fastest to deploy, fine-tuning improves domain accuracy, and RAG grounds your responses in your data. And finally, evaluate trade-offs. More capable models cost more, faster models may reduce quality, and customization adds maintenance overhead. The key exam takeaway: don't default to the most advanced solution. Choose the simplest option that meets the business need. Another skill on the exam will be knowing the difference between pre-trained and fine-tuning models. And pre-trained or foundational models are trained on the largest data sets and can handle a wide variety of general tasks out of the box, making them the fast to deploy and cost-effective. And of course, the fine-tuned models are, they build on those pre-trained models. They add specific training, improve accuracy. And the key exam takeaway is to carefully consider the fine-tuning. Start with prompting or retrieval augmented generation first, and then consider fine-tuning when simpler approaches can't meet the requirement. Now let's look at cost drivers in generative AI. The exam doesn't expect deep pricing knowledge, but it does expect awareness of what impacts cost and value. So the first thing to consider is tokens. Every request includes input and output tokens, and longer prompts or responses directly increase the cost. So next, think about just API usage. Infrastructure like compute, storage, networking can all contribute to the overall cost, especially in more complex situations. So consider the total cost of ownership. This includes things like fine-tuning, data preparation, and maintenance systems like RAG pipelines over time. And finally, the cost is always evaluated against return on investment. So the value comes from time savings, productivity improvements, and quality outcomes, not just lower spending. The key exam takeaway: don't focus on cost alone. Always think in terms of cost versus business value and choose approaches that balance both effectively. The exam will test our knowledge of the challenges with generative AI. Understand fabrication, sometimes called hallucination, when the model produces content that sounds correct but isn't accurate, and you'll need to differentiate the concept that the same prompt can produce different outputs, and the consistency can vary depending on the task. So models learn from training data so they can reflect or amplify biases that exist in data. So because of these challenges, it's important to think about mitigation approaches. This includes grounding the responses in trusted data, applying content filtering, and using human review where needed. The key exam takeaway here is generative AI is powerful, but it's not perfect. You're expected to recognize the risks and to choose the solutions that reduce them appropriately. Now let's focus on when generative AI actually provides the business value. So this is going to be all about the scenario recognition. First, look for high-value use cases for content creation, customer support, document processing, and anything involving a large volumes of unstructured data are strong signals for generative AI. Next, consider scalability. The exam often tests whether the solution can handle high volume, run continuously, and deliver consistent output without increasing human effort. You also need to think about automation versus augmentation. Scenarios favor AI assisting humans, not fully replacing them, especially in business-critical scenarios. Also, you will need to know when not to use generative AI. Determine if traditional machine learning or rule-based systems are the better choice. The key exam takeaway here: focus on where generative AI creates value through scale and efficiency, but also know when a simpler, more deterministic approach is the better fit. All right, now let's focus on the impact of prompt engineering. This is going to be about understanding how input design affects the outcomes. So first, we know that prompt engineering directly impacts the quality and consistency, and better structured prompts lead to more reliable outputs and reduce rework. So from there, we're going to consider the cost. Every token in a prompt contributes to overall consumption, so inefficient prompts can increase cost quickly. So you should also recognize that prompt engineering is often the first step. Before changing models or exploring fine-tuning, improving the prompt is typically the simplest and most effective option. Another key point for the exam is consistency. Using structured prompts or templates helps standardize outputs across users and scenarios. The key takeaway: prompt engineering is a high-impact, low-cost lever for improving AI solutions, and it should be considered before more complex approaches. Now let's focus on grounding. This one is one of the most important concepts for reducing risk in AI solutions. So from an exam perspective, we need to recognize when grounding is required. Any scenario involving organizational data, up to data information or accuracy requirements, is going to be a strong signal. So we should also be thinking about our data quality. So grounding depends on accurate, current, and well-structured data sources. Poor data will lead to poor outputs. So another key area would be the architecture. Look for the scenarios that involve retrieval, indexing, or connecting AI to external data sources. These are indicators of grounding or RAG-based approaches. So consider governance. When AI interacts with enterprise data, access control, compliance, and data security become critical factors. And the key exam takeaway here is use grounding when accuracy, data relevance, or enterprise context matters, and always consider data quality and governance as part of the solution. Now let's focus on RAG, retrieval augmented generation. First, review the core pattern of RAG. The model retrieves relevant data, adds it to the prompt context, and generates a response. And then next, recognize when RAG is the right choice. So look for scenarios involving organizational data, frequently changing information, or the need for accurate source-based responses. You should be thinking about retrieval quality. If the wrong data is retrieved, the output will still be incorrect, even if the model is working as expected. Another key exam concept is the implementation of patterns. You may see references to basic retrieval, multi-step retrieval, or more dynamic tool-driven approaches. And finally, understand the comparison with the fine-tuning. In most cases, RAG is preferred when data changes often or needs to remain controlled and attributable. The key takeaway, understand RAG grounding in AI enterprise data and recognize when retrieval and context matter more than modifying the model itself. All right, now let's focus on the impact of data on our AI solutions. So first, consider the data types. The exam is going to expect us to understand and distinguish between structured, semi-structured, and unstructured data, and understand how solutions are designed. And then next, think about the data quality. If the scenario mentions inaccurate outputs, inconsistencies, or outdated results, that's usually pointing to issues with data quality, not the model itself. We also need to recognize data sets and their representatives. Like if certain groups or scenarios are missing from the data, that can lead to biases or poor performance, especially in edge cases. And finally, consider the governance. Look for signals around data ownership, access control, compliance, and data lineage. These are critical when AI is used in enterprise environments. The key exam takeaway, AI performance is directly tied to data quality, and you're expected to identify when data, not the model, is the root of an issue. Now let's focus on secure AI. So first, let's understand the core security principles, confidentiality, integrity, and availability, and apply that to AI systems and their data. And next, be aware of the threat landscape. So look for signals like prompt injection, data leakage, and model misuse. These are common exam scenarios, and you should also recognize responsible AI as part of the security. This includes fairness, transparency, accountability, and ensuring AI behaves safely and predictably. Governance is another key factor. Scenarios involving policies, auditing, monitoring, or compliance requirements are strong indicators of secure AI practices. And finally, think about how these risks are mitigated. Content filtering, access controls, monitoring, common patterns. Those are the common patterns that the exam expects you to identify. And our key takeaway here is that secure AI is not optional. It's built into the solution, and the exam expects us to prioritize safety, governance, risk mitigation in every scenario. And now let's talk about machine learning. Machine learning adds value, and choosing the right approach is going to be based on the task. So first, identify the type of problem. If the scenario involves classification, prediction, recommendation, or anomaly detection, that's a strong signal for traditional machine learning. And then consider the data. Structured, labeled, numerical data typically points to machine learning rather than generative AI. You should also think about output requirements. If the solution needs consistent, repeatable, and measurable results, machine learning is usually the better fit. Another key factor is the business value. Look for scenarios involving automation of decisions, real-time processing, or detecting patterns at scale. And finally, apply a simple decision lens. If the task is analyzing data and producing a prediction or category, choose machine learning. If the task is generating content, choose generative AI. The key takeaway, don't default to generative AI. The exam is going to expect us to recognize the differences between traditional machine learning and the more accurate and efficient and the appropriate choice. So let's focus on the life cycle of machine learning as a solution. This is about recognizing the stages, not memorizing details. So first, consider data preparation. The exam is going to signal that this is the most time-consuming and critical phase, and issues here are common root causes of failure. And then we're going to look at training and evaluation. Scenarios may reference model performance. overfitting, underfitting, or evaluating metrics. These are all indicators of this stage. You also need to recognize deployment. So when the model is being used in a real-world scenario, think about availability, monitoring, and integrating into other systems. Finally, consider continuous improvement. The exam often highlights model drift where performance degrades over time, requiring monitoring and retraining. The key takeaway: machine learning is an ongoing life cycle, not a one-time deployment, and the exam expects you to identify issues and decisions across all stages of that life cycle. All right, let's talk about security considerations for AI systems. This is about recognizing risks across the full solution. So firstly, think about application security. If the scenario involves user input, prompts, or outputs, look for risks like prompt injection, improper input handling, or unsafe outputs. Next, consider the data security. We should be evaluating how data is protected at rest, in transit, and during use, especially if sensitive or regulated data is involved. Authentication and authorization are also key signals. Look for scenarios where identity, access control, and role-based permissions determine what the AI can access or return. You will also need to recognize any compliance requirements related to that. If the scenario references privacy laws, auditing, or regulatory controls, security and governance are part of that solution. Key takeaway here: security in AI spans application, data, access layers, and the exam is going to expect you to identify the risks and controls across all of these. This completes Objective 1. Focus on understanding when to use generative AI, how to select the right solution, and how to evaluate cost, risk, and business value. Now let's discuss the benefits, capabilities, and opportunities for Microsoft's AI apps and services. This slide outlines everything covered in Objective 2, which focuses on Microsoft's AI apps and services. We'll walk through how to map business scenarios to Copilot, understanding capabilities across Microsoft 365, and know when to extend or build using tools like Copilot Studio and Foundry. The key to this objective is to recognize the right tool for the right scenario. Here, we're going to focus on how to map real-world business processes to Copilot use cases. The key idea is simple: identify where people are spending time on content, communication, or analysis, and look for opportunities where Copilot can assist. Remember, Copilot is best used to augment knowledge work, not replace decisions or handle deterministic tasks. And here we're going to highlight the differences between Copilot versions. The key distinction is whether the solution needs access to organizational data. Across M365, Copilot uses Microsoft Graph and respects permissions, while General Copilot works with public information only. For the exam, when you see internal data, security, or compliance requirements, think Microsoft 365 Copilot. Know that app-embedded Copilot is driven by context. Each Microsoft 365 app aligns to a specific type of work and content. Be clear on core mappings and expect scenario-based questions. The exam may describe the task and not the tool. You must map the action to the correct application, such as drafting a document indicates working in Microsoft Word. Understand the key distinction between app-based Copilot use in in-place context, such as Word or Excel. Copilot Studio is a low or no-code way to extend Copilot. You will be expected to identify when customization is required and when M365 Copilot Chat is the appropriate solution. Recognize that this is about predictable, governed behavior, not general AI capability. Use Copilot Studio when Copilot alone is not sufficient. Understand positioning. Do you need M365 Copilot Basic and Premium with no cost customizations, or does the scenario require Copilot Studio or a custom Azure AI Foundry solution? Expect scenario signals around business rules, internal workflows, or required control over outputs. Know that Copilot Studio is the middle ground option, extending capability without full custom coding and development. You will be expected to understand that Microsoft Graph is the foundation for how Copilot works with organizational data. Identify its role. It's connecting users, files, emails, meetings, and activities into a unified data layer. Be clear on permission-trimmed access. Copilot can only return data the user is accessed or authorized to access. Know that this is enforced automatically through existing Microsoft 365 permissions and controls, and recognize contextual reasoning. Graph-enabled Copilot enables Copilot to connect our information across the emails and meetings and documents and chats. Expect scenario signals around organizational data, security, or personalized responses. And know that when Copilot is reasoning over work content securely, Microsoft Graph is the underlying capability. And we need to know that integrated Microsoft AI solution combines Copilot, Graph, identity, compliance, and responsible AI into one system. Recognize a key value. AI works inside existing tools with built-in security and governance. Identify business benefits, faster productivity, consistent experiences, and reduced need for custom solutions. Understand risk mitigation, identity-based access, the permission trimming, the DLP and auditing, and content safety. Recognize they're built in. Expect scenario signals around sensitive data compliance requirements or enterprise scale deployment. Know the comparison. Integrated Microsoft AI is preferred over standalone tools when security, governance, and organizational data are required. Be ready to select the option that meets the requirements best with the highest level of built-in control and lowest risk. Know that this is about mapping the business process to the simplest Microsoft AI solution that fits. Identify the categories. So internal productivity, Microsoft 365 Copilot, controlled customization, Copilot Studio, custom or external scenarios, use Azure AI Foundry services. Recognize the scenario signals. So internal, employee-focused tasks map to Copilot, policy-driven or guided workflows map to Copilot Studio, and customer-facing or advanced systems map to Azure AI services in Foundry. Understand the decision principle. Choose the least complex solution that meets the requirement. Expect comparisons between tools. Correct answers will prioritize the fit, the security, and the overall capability. Be ready to match the process, not the product name, to the right solution. We're going to need to know the distinction between some of the agent tools like researcher and analyst in Copilot. So researcher is synthesis, exploration, and structured narrative output, and analyst is data interpretation, metrics, and evaluating insights. So recognize the type of differences. Researcher produces descriptive report style content, and the analyst produces data-driven conclusions and comparisons. Expect scenario signals. So research, summarize, compare concepts. It's going to map to researcher, and analyze, evaluate trends, metrics. It's going to be analyst. Understand the intent-based agent selection. Make sure to know how to interpret the task and find the correct tool. When both could apply, choose based on the primary output. So knowledge synthesis versus data analysis. Know the build, buy, and extend decision model. So buy out of the box, Copilot for common productivity scenarios. Extend, use Copilot Studio when customization and business rules or integration are required. And build uses AI Azure services and Foundry when the solution is external, highly specialized, or goes beyond assistant-style interaction. Recognize the progression. Start with buy, move to extend, build only when necessary. Expect scenario signals around internal versus external use and the need for control and the level of customization. Know the exam principle. Choose the simplest solution that meets the requirement with the least complexity and highest alignment to governance. Know that Foundry tools are used when AI becomes part of a business system, not individual productivity. So recognize the core signal, building, orchestrating, or managing AI solutions at scale. Identify when to map to Foundry. So end-to-end AI workflows, multi-step pipelines, enterprise operations, and repeatable processes are all going to be keywords. Understand that this is lifecycle coverage development, so development, deployment, and monitoring, and expect governance and control signals. So the monitoring, evaluation, compliance, and oversight. Recognize scalability indicators, enterprise rollout, ongoing operations, cross-system integration, and know the distinction. So Copilot is for using AI, Foundry is for running and managing AI at scale. You'll need to know how to map specific pre-built capabilities for language, vision, speech, and decision tasks to business needs. For example, you'll need to know that Azure Vision maps to image analysis and optical character recognition and visualized data processing. Understand other sources such as Azure AI Search, which is critical for RAG solutions. And know that Microsoft Foundry platform is a layer for building, managing, and governing these AI solutions. Recognize scenario signals and understand capability matching, so choose the right service for the role, not the most complex option. So we need to know how to match the task to the model type. So generative models, content creation, summarization, conversations, and reasoning over text. Traditional machine learning models, classification, prediction, anomaly detection, and structured data analysis. And recognize the key decision signal, creating content, generative AI. Analyzing or predicting, machine learning. So expect scenario cues around data type. Unstructured data, generative AI. Structured or numerical data, machine learning. Account for constraints, cost, latency, accuracy, and compliance requirements. And know the exam principle. Choose the simplest model that meets the business needs, not the most advanced option. So we need to know the key benefits of Microsoft Foundry at the enterprise scale. So the primary value, a unified platform for building, deploying, and managing AI solutions. We want to identify scalability signals, growing usage, enterprise rollout, and repeatable AI operations. Understand that Foundry supports scaling from pilot to production without redesign, and then recognize security and governance as core differentiators, identity-based access encryption, monitoring, and policy enforcement. So expect scenario signals around compliance, risk reduction, and operational control. And know that Foundry is chosen when AI must be managed reliably over time, not just implemented once. So be ready to select Foundry when the requirements include scale, security, and long-term AI operations. In summary, Objective 2 focuses on recognizing how to map business scenarios to Microsoft AI solutions, including Copilot capabilities and Foundry tools based on fit, value, and control. Objective 3 focuses on how to implement and scale AI across organizations, including responsible AI, governance, and adoption strategy. Know that this objective focuses on implementation and adoption strategy, not just capability selection. Identify the two core areas: responsible AI alignment, organizational adoption planning. For responsible AI, it's going to be clear on governance and principles and oversight structures and alignment to standards like fairness, safety, and privacy and accountability. And recognize signals around establishing governance, defining the policies, ensuring AI solutions meet responsible AI requirements, etc. For adoption, know the operational focus. Adoption teams, AI champions, barriers to adoption, the impact on data, security, and privacy at cost. Expect scenario signals around scaling usage across organizations, not just initial rollout, and be ready to identify how organizations move from deploying AI to driving sustained governed adoption. So, knowing why responsible AI is foundational to enterprise operations or adoption is important. We need to identify the core purposes, building trust while preventing harm and risk. Recognize key principles: fairness, reliability, safety, privacy, transparency, and accountability. Expect scenario signals around risk reduction, bias, unsafe outputs, or unintended consequences. Understand human accountability. AI assists, but humans remain responsible for decisions. Look for alignment to organizational values and compliance and governance requirements. Be ready to select answers that prioritize safety and are trustworthy and are governed AI use over speed and capability. We need to know that AI governance defines how AI is used, controlled, and monitored across the organization. So identify the purpose aligning the AI use with risk tolerance and compliance and other business goals. So we need to recognize that governance scope, data handling, model selection, deployment, and ongoing monitoring across the full lifecycle are important, and expect scenario signals around inconsistency, lack of standards, or uncontrolled AI usage. Understand the need for consistency. Common policies apply to across all the teams and all of the solutions. And know that governance includes ongoing oversight and must evolve as AI and regulations change. And be ready to select answers that introduce structure, accountability, and repeatable controls for all the AI use at scale. So know that an AI council is the central body for guiding the AI strategy and governance, and we want to identify its purpose. So aligning AI initiatives with business goals and managing the risk at scale. Recognize scenario signals around fragmented efforts, unclear priorities, or inconsistent AI usage. Understand the oversight role, reviewing use cases, enforcing responsible AI, and managing risk. Know that it drives cross-functional alignment across business, IT, legal, and compliance. Expect scenarios where coordination, accountability, or decision ownership is missing. Be ready to select an AI council as the structure that enables consistent governed AI adoption across the organization. So we need to know the core responsible AI standards and how they are applied in practice. So identify the key categories. Again, it's the fairness, reliability, safety, privacy, security, transparency, and accountability. And recognize fairness and inclusiveness signals. So avoiding bias, ensuring equitable outcomes across users, and understand reliability and safety, which is consistent, accurate outputs, and safe handling of edge cases. Expect privacy and security scenarios, protect sensitive data, and enforce access controls would be key phrases. So no transparency and accountability. So users understand AI involvement and humans remain responsible. Be ready to select answers that ensure AI systems are trustworthy, governed, and aligned to these standards on end-to-end solutions. Know that an adoption team drives actual AI usage, not just deployment. Identify its role, translating strategy into day-to-day adoption and behavior change. Recognize cross-functional ownership from business, IT, security, and compliance. Everyone is involved. So expect scenario signals around low usage, confusion, or lack of enablement. Understand core activities, so communication, training, feedback, and hands-on support. And know that this is ongoing, not a one-time rollout or one-time training event. Be ready to select an adoption team when the focus is scaling consistent real-world AI usage across an organization. And one of the common barriers to AI adoption are primarily people, the trust, processes, and leadership, not the technology. So identifying people-related barriers, fear of job impact, low confidence, and lack of skills or training. We want to recognize trust gaps and concerns about accuracy and privacy and bias and reliability that limit the usage. So expect process misalignment, so AI not fitting existing workflows or lacking clear guidance, understanding leadership signals, unclear ownership, weak prioritization, or conflicting direction. Know that low usage indicates adoption failure, not capability failure. So be ready to select solutions that address change management, trust, and alignment to drive adoption at scale. And we'll need to know that AI champion programs drive grassroots adoptions through peer influence. So identify the purpose. Normalizing AI usage and reducing hesitation through real-world examples. Recognize who champions are. There's going to be trusted practitioners and early adopters, not typically leadership or IT. Expect scenario signals around low engagement, need for practical guidance, or cultural adoption gaps, and understand the core activities, sharing use cases, helping peers, and feeding back adoption challenges. So note that this complements adoption teams and governance. It reinforces the usage within the teams itself. So be ready to select an AI champions program when the goal is scaling adoption through trust and peer-driven enablement. And one of the key impacts of AI adoption across data, security, and privacy and cost will be the identifying the data impact. So AI increases reliance on high-quality data and exposes gaps in governance and access. Recognize security impact, expanding risk and the risk surface, and greater need to identify identity-based controls and data protection. Expect privacy signals, AI interacting with sensitive or regulated data in new ways, and understand cost impact, where consumption-based models that scale with usage and require those governances. Recognize these as second-order effects, issues that emerge as AI adoption grows. Be ready to select answers that address readiness, risk management, and cost control alongside AI implementation. Know the different Copilot licensing models and when each applies, including or the included licensing. So baseline access, it's broad exposure, low barrier to entry, and then monthly licensing is predictable cost, targeted rollout for high usage roles, and pay as you go. It's flexible, it's consumption based, best for pilots and variable usage. Recognize scenario signals around adoption stages, early exploration, targeted deployment, or scaled usage. And we need to understand that licensing aligns to maturity, starting broad and then refining to specific roles. Be ready to select the model that balances access, cost control, and business value for the scenario. Know that Azure AI subscription models and when each is appropriate. So the pay-as-you-go, usage-based, flexible, based for experimentation and variable demand. Prepaid, which is committed usage, predictable cost, best for steady production workloads. And recognize the scenario signals around adoption stages, so pilot versus scaled deployment. And then we need to understand that our organizations typically move from pay-as-you-go to prepaid as usage stabilizes. We know that subscription models are part of the cost governance, not just billing. Be ready to select the model that aligns with the usage patterns, so cost predictability and adoption maturity. Objective 3 focuses on how organizations implement, govern, and scale adoption across and responsibility across people, processes, and the enterprise controls. So thank you for joining Preparing for Exam AB-731 AI Transformation Leader Exam Prep. Continue your preparation using the official study guide and resources at aka.ms/AB731, and we wish you the best luck on your exam.